Hey my fellow alchemists, today we are going to synthesize copper acetate using a little bit of vinegar and copper sulfate. In future videos, I will show you exactly how to obtain this gorgeous blue copper sulfate. Here is the molecular structure of copper acetate. As you can see, it's a dark green compound that looks incredibly exotic. Copper acetate can actually exist in two forms. The first is copper acetate monohydrate, meaning its structure contains a linked water molecule. The second is anhydrous copper acetate, which is completely free of water. This compound has a ton of industrial applications. In organic chemistry, it's incredibly useful as a catalyst for cycloadditions and cross-coupling reactions. It's also used in the agricultural sector as a fungicide for crops, and it even helps in manufacturing certain pigments. But anyway, let's get into the synthesis. We are going to need 2 grams of copper sulfate pentahydrate, 0.64 grams of sodium hydroxide, and 80 milliliters of vinegar. Our first step is to react the copper sulfate with the sodium hydroxide to create copper hydroxide. This is a beautiful blue copper compound that is insoluble in water, meaning it's going to precipitate out of the solution. After that, we will react this copper hydroxide with the acetic acid from the vinegar to finally get our copper acetate. First, we dissolve the copper sulfate into 30 milliliters of water. Just look at that beautiful blue color as it goes into solution. Meanwhile, we also need to dissolve the sodium hydroxide into 20 milliliters of water. As always, be very careful when dissolving this compound. It's highly exothermic, so the solution will get quite hot. Now that both compounds are dissolved, it's time to proceed with the reaction. We slowly pour the sodium hydroxide solution into the copper sulfate solution. While doing this, we need to stir continuously because a blue compound starts precipitating almost immediately. This is our copper hydroxide, which, as I mentioned, is insoluble in water. The chemical reaction happening here looks like this. 1 mole of copper sulfate reacts with 2 moles of sodium hydroxide to form 1 mole of copper hydroxide and 1 mole of sodium sulfate. Once the addition is complete, we need to let the precipitate settle for a full day. This helps us remove impurities caused by co-precipitation, specifically absorption and occlusion. Absorption impurities happen when there are oppositely charged ions in the solution. These attach to the surface layer of the precipitate due to electrostatic attraction. Occlusion occurs when impurities get physically trapped inside the compound's crystal lattice due to the rapid formation of the precipitate. Anyway, after letting it sit for a day, I came across a surprise. The precipitate suddenly turned black. This wasn't exactly part of the plan, but the experiment must go on. What happened here is that copper hydroxide is a very unstable precipitate. It starts decomposing into copper 2 oxide when heated, or sometimes just by resting in an aqueous solution. But don't worry, this won't be a problem, and the experiment will still be a success. Now, we need to filter this black precipitate. The goal is to recover as much copper oxide from the beaker as possible, so we will wash the beaker with water a few times to get it all. Once we have collected all the copper oxide in the filter, we transfer the precipitate to another beaker. This is where the acetic acid comes into play. We carefully add the vinegar to the beaker and slowly the black precipitate starts to disappear. This happens because the copper oxide is reacting with the acetic acid to form copper acetate. Since copper acetate is soluble in water, the solution will gradually turn clear. Just to be safe and ensure the reaction is completely finished, we filter this beautiful new green solution to remove any unreacted materials. At this point, we just need to concentrate the solution. I placed the beaker on a hot plate to evaporate off some of the water until we were left with about 40 milliliters of solution. Right around this time, some particles start to precipitate. This could be impurities from the vinegar, but not big deal. We just need to do a hot filtration to remove them. Now we simply let the solution rest so those nice copper acetate crystals can't start forming. After a few days, some copper acetate crystals have formed. They are a bit small, but look at them. They are absolutely beautiful. Now we just filter out these nice crystals and let them dry in the filter for a bit. Also, if we want to recover the maximum possible amount of copper acetate from the solution, we could evaporate all the water to get a nice copper acetate powder. The downside of this method is that impurities from the vinegar might also precipitate out, contaminating our final product. And well, that's it for today's video. I hope you like it, and don't forget to subscribe and drop a comment and hit that like button for more alchemy, chemistry.